Welcome back everyone. Welcome to this particular lecture of FPGA. Full form is Field Programmable Gate Array. So FPGA is nothing but a computer chip. This chip can be programmed or configured by the user after manufacturing, unlike the other design chips that are already designed for some fixed purposes. Okay. Now, while designing the FPGA, the engineer will first write a specialized code using hardware description language or HDL. This is nothing but a very high level programming language which is used to model the hardware systems. Okay. Now, while the designer or engineer will write the code in order to specify the logic gates of the FPGA connection switches, how those can be programmed. So the engineer will write a code using HDL, and that code will be compiled to a program file. After that, that program file will be loaded onto the FPGA in order to perform the desired operations. So if you want to look at the internal structure of the FPGA, what we have, you can see here some red boxes and some blue boxes. So these red boxes are called CLB or configurable logic blocks. Okay. So they are basically responsible for actual processing or the logical implementation. So it is also possible for the user to program these CLBs in order to perform the basic logic functions like AND, OR, XOR, etc. Then what else? What is the other component? These blue boxes. These blue boxes are the switch boxes. They are the interconnection switches. So what is their job? Their job is to make sure that all parts of the FPGAs are interconnected to each other. Suppose if a signal is generated or processed at one part of the FPGA, the job of the switch boxes is to ensure that generated signal it reaches to the other part of the FPGA. That means they make the complex digital operations much simpler. Apart, these two are the main components of your FPGA. Apart from that, we have these blue color lines which are called connections. So CLBs are connected to this SV using these blue color lines. Now, what else we can see here? We see these black color arrows at the periphery of the CLBs or the outer edges of the CLB. They provide basically the input-output connections for some external device or other signals. Now, if you zoom in this CLB, what we have inside the CLB? We have a lookup table, in short LUT. It is nothing but a black box, and it is a small memory cell which helps in logical functions. Then output of the lookup table is given to the mux or multiplexer. So this multiplexer is a huge topic in digital electronics. So just to give you a short idea, multiplex means many into one. Multiplexing is a process of transmitting large number of information over a single line. So this multiplexer is basically the digital circuit that performs or that selects only one input among several available inputs and generate only one output. Okay. So for example, if you consider, let's say, this is a multiplexer. Okay. What I told, it has several inputs, right? It has several inputs. And it will select only one input among several available inputs, and it will generate only one output. Now the question is, based on what it will select only one input? For that, it has some select line. Okay, select line. Now let's say if you have n input line and m select line, okay, and one output. Okay, now if you consider, if small n if that is equal to, let's say, 2 to the power m, then it can be said that m select lines are required to select only one input among the several available n input line and to generate only one output. Okay, so if I want to select, suppose there are 4 input lines. If I want to select one input among the 4 available input lines, then how many select line I need? 2, because 2 square equals to 4. Okay, similarly, if I want to select one input line among 8 available input line, then how many select lines we need? 3, because 2 cube equals to 8. Okay, let's say I want to design a 4 cross 1 multiplexer. 4 cross 1 multiplexer. Okay, so in this 4 cross 1 multiplexer, it means it has 4 inputs and 1 output. Okay, so what this multiplexer will do, it will each time it will select only one input and it will give that input to the output. Okay, let's say it has 4 input and 2 select line. Let's say 2 select line, one is S1, another one is S0. Okay, so with 2 select line, how many combinations we can make? 4. Both can be 0 0, 0 1, 1 0, 1 1. So when S1 S0 both are 0, what will happen? Let's say this first input is selected and it goes to the output. Next, when it is 0 1, then second input is selected, it goes to the output. When it is 1 0, third input is selected, it goes to the output. When it is 1 1, fourth input is selected, it goes to the output. So that is how multiplexer works. So here the output of the lookup table, it goes to the multiplexer. Multiplexer, what it will do, it will select only one data among several available output data of the lookup table and it will generate the output. Now here we can see there is another circuit. This is nothing but a flip-flop. Okay, this flip-flop is also a huge chapter in digital electronics. So what this flip-flop does, it will store the binary information. Here we are using the D flip-flop. We are giving, that means the output of the lookup table, it is momentarily stored in this flip-flop. Okay, so this D is the normal input of the flip-flop and this arrow symbol you are observing, this is nothing but a control signal. Okay, so in order to make the flip-flop work, we need 2 inputs. One is normal input, another one is a control input, and Q is the normal output and Q bar is the inverted output. Okay, now here we are giving the positive control signal. This control signal is nothing but a clock signal. Okay, clock signal is nothing but a 0 1 0 1. It is a digital signal. Okay, so what happens here, this means a positive clock, positive age triggered clock. That means when this clock signal, clock we write in short as CLK. Okay, so when the clock signal goes from 0 to 1 or low to high, then only if you give input to the D, you will get the output. Until and unless you give the clock signal, doesn't matter what input you give to the D, it won't generate any output. When the clock signal is high or clock signal is going from 0 to 1, if you are giving 0 at D, output Q will be 0. It will follow the input D. When the clock signal again, when it is high, that means either it is completely high or it is going from 0 to 1. That transition is happening. If you give 1 here, output Q will be 1 and Q bar will be 0. So that is how your FPGA works.